In this video, we are going to go over how to exercise the rule of what happens when we raise a numerator over a denominator to an nth power. And we know this rule from a previous video and why it works. Now we're just going to exercise how it works. It separates into a to the n over b to the n. Essentially, you're distributing that power to both the numerator and denominator. Without any further ado, let's look at 4 examples. Okay, so we've got 3 over 4 squared. Applying this rule, we've got our numerator is 3, our denominator is 4, so we're going to raise both 3 to the second power as well as 4 to the second power. And what we have left from there, we've got 3 squared, which is 9, all over 4 squared, which is 16. Very simple. 9/16 is our final answer. We've applied our rule. Now let's look at some variables in a fairly straightforward problem. In this case, a, the numerator is x squared and the denominator is m. So we're going to raise both the numerator, x squared gets raised to the 4th power. This is what's going on in my mind. You might not necessarily write out the step. And then m is raised to the 4th power. Well, there's nothing to simplify there. Now, x squared to the 4th power, we know that when we raise a power to a power, we multiply the powers. 2 times 4 is 8, and so we're left with x to the 8th all over m to the 4th. That's it. Not so bad, right? Not so bad. Let's look at letter C. I'll spin around for that one. So in letter C, you've got a numerator, negative 5x, over a denominator y cubed. We are going to apply this rule. We are going to raise everything in there to the second power, so that's equal to negative 5x, all of that to the second power, that's the entire numerator, all over y cubed squared. Now again, if you get really good at this, you might not be showing out this work, but it doesn't hurt when you start to do these kinds of problems to show out this work first, so A, you can follow what your thinking was when you look back on your work, and B, maybe a teacher can check out and see, oh yeah, this is what went right, or this is what went wrong, and this is how we need to make ourselves better. Okay, so after a while though, we'll be doing it mentally, which is great. So negative 5x squared, remember, we are raising everything to the second power. So negative 5 is being raised to the second power, and negative 5 squared, or negative 5 times negative 5, is positive 25. And then x also gets raised to the second power, so that's x squared, all over y cubed squared, power raised to a power, so we multiply the powers. 2 times 3 is 6. So you get y to the 6th power. So 25x squared over y to the 6th. Not bad, not bad. Okay, this final problem, you could do this in one of 2 ways. You could certainly observe what we did here and raise the entire numerator to the 4th, all over the entire denominator to the 4th. I choose to do this kind of problem a different way. What is different in this problem than in the other 3 problems, we couldn't simplify any of the fractions before raising to the power on the outside. But in this problem, we can. We have common factors in the x's and in the y's where we can use exponent rules to reduce what's going on there. So I'm going to do that first, then I'll raise everything to the 4th power. So the order of operations yet again comes into play. So I look at this, the 3 does not have a common factor with which it will reduce in the denominator. So let's leave that alone. However, you have x squared over x to the 4th. So I'll do a little bit of side work. X squared over x to the 4th. If you recall, we subtract numerator exponent minus denominator exponent. So it's x to the 2 minus 4, which is x to the negative 2. Ah, very nice. So what we have left now with the y's, and we'll check out how that plays in, but with the y's, we have y to the 5th over y squared. Well, that's going to be y to the 5 minus 2, subtracting exponents, which is y to the 3rd. Okay, so everything boils down, and you kind of have a choice of how you want to write this back in there. I'm going to do it as so. We had x to the 2 minus 4 is x to the minus 2. We had the 3 hanging out. If it was x to the minus 2, we get x squared in the denominator, and that is an awfully long fraction bar. That goes in the denominator because, again, of the negative exponent. And then here we have positive y cubed, so that's in the numerator. So we've simplified everything down. Everything in the, basically in the parentheses is broken down as far as it can go. Now we'll raise everything to the 4th. So I'll raise 3y cubed to the 4th, like so, all over x squared raised to the 4th, using our rule. Okay, so this is just a combination of things you know how to do and can control, and D is the most challenging of all these problems by far. So 3 raised to the 4th power, that's 3 times 3 is 9, times 3 again is 27, times 3 is 81. So you've got 3 to the 4th is 81, y cubed raised to the fourth. Well, that's y to the third to the fourth. You multiply 4 times 3, it's y to the 12th. And remember, what we're doing here is raising a product to a power, so that power goes and multiplies to each of the powers in there. X squared to the fourth is x to the 2 times 4, which is x to the 8th. And that's it. So a challenging problem to end it for sure, and your class might not even be there yet. Maybe you're not up to that level and you're rocking these first. Figured I'd show you all levels of ability there. Go rock some of these problems.